All right, we're going to be talking now about graphing a quadratic equation. And I always like to start with what it seems like a fairly obvious thing to say, but one of the things that there's actually a couple different forms that we can do, and I'm going to start by just sort of defining our two types of forms. We've got what we call a standard form, and our standard form looks like y equals some ax squared plus bx plus c. Something like this. This is a standard form. We also have what we call a vertex form. And the vertex form is, in a lot of ways, this is going to be the easiest thing for us to graph in. But I'm going to start by showing how to graph using a standard form, because this is probably what we're most used to seeing for now. But this vertex form is y is equal to a times some x minus h squared plus k. And here, the vertex is located at h and k. So let's start by, I'm going to start by graphing something. Actually, I'm going to graph the easiest quadratic equation there is. So y is equal to x squared. Now, this is the easiest one there is simply because if I were to show the pattern, with my x and my y, I'll do something like -3, -2, -1, 0, 1, 2, and 3. And we can see this pattern really, really simply. And because this is an x squared, we're going to see what the standard pattern for a parabola is. So here, if I've got, y is equal to, say, -3 squared, that's going to be 9. -3 times -3 is 9. -2 times -2, 4. -1 times -1, or -1 squared is 1. So we seem to be going down. 0 squared, 0, no, still going down. And then 1 squared is 1. Now it's moving back up again. 2 squared, 4. 3 squared, 9. So, like I said, this is we always start with the easy stuff. And now let's go ahead and graph this. Now, we notice that, I want you to notice here that we have that around this point, we have, essentially, we're having these equal values. We have symmetry. That's because when I graph any kind of quadratic, I'll put this up here, I'm going to have, well, we have symmetry. Let's see, here's my y. And when I was at -3, it was up at 9. When it was -2, it was at 4. When it was at -1, it was at 1. 0, 0, 1, 1, 2, 4, 3, and 9. And so when I graph this, I have a shape that looks like this. This is a fairly standard parabola. Now here is one of the really cool things to notice. If I were to take this, if you're well, this point right here, this is our vertex. Right here at that lowest point. Now, the interesting thing that we'll see is as we move out from that lowest point, if it moves out 1, it moves up that same value squared, 1 squared. If it moved out 2, it moves up 2 squared. If it was 3 away, if the x value is 3 away from the vertex, it moves 3 squared away from the, up from there. This is that, and this is the pattern. Once you know where that vertex is, then that distance squared is the essentially the rise. Now, one of the things that's really, some of the things that are going to be, that are also going to impact this is if I have any number in front of this. If I had another number in front of this, I would also need to multiply that square. So if this were a 2x squared, then this would be 2 times 1 squared, or 2 times 2 squared, or 2 times 3 squared. That's something that will impact that pattern. But as soon as you know where that vertex is, you know where to center everything else. So let's show you how to find your vertex. And I'm going to, once we show you that, I'm also going to show you, well, let's start one thing at a time. So from something like this, y equals, again, this ax squared plus bx plus c. I'm going to show you how to find your important points. And the first thing is your vertex. Your vertex, of course, is, this is your either highest or lowest point. Your vertex, we usually give our values as h and k. And the h value, this is just the x portion of that, is negative b over 2a. So there's that. For the k, this is just that function with h in there. If we're to find our x-intercepts, we're going to set the y equal to 0 and solve. For the y-intercepts, and you'll only have one y-intercept, if it's in this form, basically as soon as you set x equal to 0, then y is just going to be equal to c. So it's just going to be 0c no matter what. Now that I've said all that, let's go ahead and do an example. So let's do this. Let's say we've got y is equal to x squared minus 4x minus 5. And first things first, let's find our vertex. So our vertex, let's find the h value. That's, like I said, negative b over 2a. So this means that the x value of that is going to be negative 4 over 2 times 1. So this looks like my h value is going to be at 2. Because here I've got a equals 1, b equals negative 4, c equals negative 5. Now that I know that what my h is, I'll find out the k. K is what happens when I plug in this h into my formula. So this is going to be, that's just 2 squared minus 4 times 2 minus 5. I'm cramming myself off the page here. So k is going to be equal to 4 minus 8 minus 5. And it looks like I've got, what is that? K is equal to negative 9. So my vertex is going to be located at 2, negative 9 is my vertex. So I've got one very good point right there. Next, let's go ahead and let's find our x-intercepts. So for our x-intercepts, remember I said we're going to set that y equal to 0. And some of these, not all of them, are going to be relatively easy to factor. So when I set this equal to 0, I'll be able to factor this. And I'll have, in this case, I'll have x plus 1 and x minus 5. As you already know, there are several different ways to do this. But here we can just say, okay, x plus 1 equals 0. So x would be negative 1, or x minus 5 equals 0 gives us a value of x equals 5. So I've got my two x-intercepts right here. I've got negative 1, 0, and 5, 0. And my y-intercept, for my y-intercept, again, this is where we just set that x equal to 0. That's going to be y is equal to 0 squared minus 4 times 0 minus 5. So y is equal to negative 5. So I've got a point of 0, negative 5. So I've got a bunch of points here now. And the nice thing here is we're also going to be able to use some symmetry to help us figure out some more. So let's take these points. I'm going to take these points and graph them. And for this, we had our vertex, we had a couple other points. Let's go ahead and set up a graph. So it looks like we've got, there's my x, here's my y. If I had, I need to extend this down a little bit. When x was 2, y was negative 9, so it's negative 5, 6, 7, 8, 9 right there. I had a point of negative 1, 0 and 5, 0. And I had this point of 0, 5 right there. Now, I'm going to point this out, and and I hope that you'll spot this. So think about the pattern that we discovered before, where if it moves 1 away, so here's this vertex. If it moves in either direction, if the x is displaced 1 there, it's going to move up 1. If it moved out 2, it would move up 2 squared. 1, 2, 3, 4, which is exactly where we have that. Or 2, 1, 2, 3, 4, that spot right there. If it moved out 3, 1, 2, 3, it would move up 9. Here or here. These shapes are always going to be exactly the same wherever a is equal to 1. These shapes are the same. And that is one of the key things to keep in mind when you're graphing parabolas. A parabola is a parabola is a parabola. All we've essentially done is, it's like we've taken this one and just shifted it to where my vertex is down here. Same shape all the time. Okay. I think that's what we're going to do. This is a good intro, so I'm going to leave this one right